In this video, we solve the question about moment generating function of binomial distribution. We also calculate mean and variance of binomial distribution from the formula of moment generating function. So now let's start. By definition of moment generating function, m of xt, x write in subscript. This is the mathematical notation for moment generating function to be used. It is equal to expected value of e power tx. When we expand this expectation, it is equal to sum of etx f of x. F of x is the probability density function, and sum notation is used due to binomial distribution belongs to the discrete family. E power tx nx px q power n minus x. Random variable x range from 0 to n. E power t x nx px q power n minus x. E power t x and p power x has a similar powers, so we can join these two numbers p and et. So p et power x ncx q power n minus x, and the random variable range from 0 to n. We familiar with this expression. This is mostly used in binomial distribution in the previous proofs also that we solved in my channel Statisticians Club. So random variable x range from 0 to n, ncx p power x q power n minus x, q plus p power n. We write it as q plus p power e whole power n, because here instead of p we use p e power t. So we write at this place of p p e t, because in this expression we use p e t power x. So our moment generating function is q plus p e power t whole power n is the required moment generating function. Now we find the mean by using moment generating function. This is the moment generating function. We differentiate above equation with respect to x. Partial over partial t m of x t partial over partial t q plus p e t power n. We write simply it as m prime x t. This is the notation that we use differentiation. So using power rule. What is power rule? When we take derivative of any variable power n, it is equal to n x power n minus 1. So when you use power rule here, take n here and then q plus p e power t n minus 1. One number decrease here, and again the derivative of this number. In power rule, when we take again the derivative, it is equal to 1. So again derivative, when we take derivative of q, it is equal to 0, because we differentiate with respect to t, so when we apply derivative to q, it is equal to 0. Here is apply addition rule, because we have in this bracket we have two numbers, we separately apply derivative of both numbers, and when we apply this number, p is the constant, it is take outside, and the derivative of e power t is equal to e power t, because for exponent, if you take derivative of any exponent, means e power x with respect to x, it is equal to ex. In our this equation, we differentiate with respect to t, and e power t, it is equal to e power t. So our final derivation is np e power t into q plus p e t power n minus 1. Putting t is equal to 0, np e power 0 q plus p e 0 n minus 1. E0 is equal to 1, np q plus p power n minus 1. Q plus p is equal to 1. So np 1 power n minus 1 np. So first it is also equal to mu 1 prime means raw moment. We can write it as, and first moment raw moment is equal to mean, and so we prove the mean of binomial distribution by using moment generating function. To calculate variance, again derivative, this is the term first derivative, so we take again derivative of this term. Np is common, it's take outside, applying partial over partial t both sides. So this is the first number and this is the second number. Here we use product rule. When you apply product to derivative of the product of two numbers, it is equal to write first number as it is and take the derivative of second number, plus sign. Now second derivative, the second number write as it is and take the derivative of first number. Np into, so first number writes it as et and take the derivative of second number. When you apply the derivative, use here power rule. We also differentiate it in to calculating mean, so differentiate with similar fashion. Power rule, take power at the start of equation and then q plus p e power t decrease power by 1, which is n minus 2, and again the derivative of the number q plus p e power t plus. Now the second, write the second number as it is, q plus p e power t power n minus 1 whole power n minus 1, partial over partial t e power t. So this is equal to mu 2 prime. Applying t is equal to 0, np e power 0 n minus 1 q plus p e power t n minus 2 0 p partial over partial t e t plus q plus p e power t whole power n minus 1 e power t. Put t is equal to 0. When you put t is equal to 0, e0 1 n minus 1 q plus p power n minus 2 p plus, here you write 1 power n minus 1 e power 0 is equal to 1. Here is 1 p n minus 1 q plus p is also equal to 1. We know this relationship, q plus p is equal to 1, so right here is 1 power n minus 2, it is equal to 1, so we left here p n minus 1. In this equation we left with p n minus 1, and in this equation 1 power n minus 1, it is equal to 1. So np into n minus 1 p plus 1. Now we want to calculate variance of binomial distribution, which is equal to expected value of x square minus expected value of x whole square. Expected value of x square is equal to mu 2 prime minus expected value of x is equal to mu 1 prime. This is the first raw moment and this is the second raw moment whole square. So write the value of mu 2 prime, np into n minus 1 p plus 1 minus np whole square. First inner product, np minus p plus 1 minus np whole square, n square p square minus np square plus np minus n square p square. Cancel out this term with this term, np take np common, 1 minus p is equal to q. So variance of x is equal to npq. If you liked video, then click on like button and subscribe my channel Statisticians Club. You can find videos on probability. I already solved discrete uniform distribution, Bernoulli distribution, and you can find all proof of all discrete and continuous distributions on my channel. If you want to see videos about mean and variance of discrete uniform distribution and Bernoulli distribution, then click the link in front of your screen. Thanks for watching.